Here we will give a solution to typical gate problems on junction field effect transistors. So we have considered two problems here. One problem is of 1999 and the other problem is of the year 2011. These problems have been taken up and solved here through two videos. It is observed that a good number of problems appear on gate examination on MOSFETs as compared to junction field effect transistors. And the problems involved are more related to device working and the construction. So you should be very clear about the device operation to effectively solve these problems. The first problem which is taken up here is of the year 1999. In this problem, one has to find the transconductance, and you can remember the expression for transconductance, or you can derive it from the standard drain current equation. As per my suggestions, best way is to derive it as has been done while solving the problem here. We read out the problem of gate 99 on junction FET. An N-channel junction FET has IDSS of 2 milliamperes and pinch-off voltage of -4 volts. Its transconductance GM in milliamperes per volt for an applied gate to source voltage VGS of -2 volts. There are four options given here. That means here in this problem we can find what is given. Here we observe that IDSS is given to be 2 milliamperes. It's basically the drain current with VGS is equal to 0. This is the maximum drain current. And VP, the pinch-off voltage, which is -4 volts, is also given to us. Now what we have to find is, we have to find the GM, the transconductance for this FET at the VGS value of -2 volts. This is what we have to find. Okay. Now we see this. The value for GM is given by delta ID over delta VGS, keeping VDS constant, and units for this are mhos. We are aware of the drain current equation. ID is IDSS into 1 minus VGS over VP whole squared. Here IDSS is the drain current when VGS is 0. Now if we take this ID and try to find out delta ID over delta VGS, we get twice of IDSS divided by minus VP. If you differentiate this, you will get -1 upon VP into 1 minus VGS upon VP. This expression also written sometimes 1 minus GM0 into 1 minus VGS over VP. So you can substitute the values here. GM is, this is 2, IDSS is 2 milliamperes, 2 into 10 power -3, because minus pinch-off voltage, 1 minus VGS is negative and pinch-off voltage is also negative. So we get 10 to the power -3, 1 minus half. So if you solve it, it comes to 0.5 millimos. So the value for GM here in this problem is 0.5 millimos, which is option B. So option B is the correct choice. So this has been a very straightforward problem of substituting the values and getting the value for GM. Normally the value for GM, the standard relation is to be derived from the drain current relation. So best way is you can differentiate the drain current equation and get the value for the GM instead of remembering the large expression for the value for GMA. Thank you.